My name is Steve Kester, and I'm a professor of electrical engineering. So the goal of the project is to develop a new type of continuous glucose monitor that has some potential advantages over existing glucose monitors. The device concept is called a graphene quantum capacitance varactor. And graphene is a very unique material. It's been in the news quite a lot lately. And graphene is known actually to be a very good sensor material. So what we're doing is we're actually taking, graphene and we're putting it into a device configuration that will turn it into a wireless sensor. And so the basic goals of the project are to verify that we can actually get graphene to sense glucose, and then to develop the basic device design that will allow us to eventually develop this wireless sensor. My expertise comes from IBM. I worked at IBM for 14 years, and I worked mostly on microelectronic devices. So I worked on silicon transistors mostly that are used in microprocessors. And so I'm very anxious to be able to come to the University of Minnesota and work with the Mayo Clinic and apply my expertise in semiconductor devices and in electronic devices in general to new applications, and particularly the application of medical devices and being able to actually work on a device that could potentially improve the lives of very, very many people that are afflicted with diabetes is very exciting to me.
So the research that I am doing, one of the main areas is to develop an artificial pancreas for such patients with type 1 diabetes. And so the artificial pancreas has various components, and one component is a device that will be able to measure glucose continuously and accurately. The current device that we have, though good and a big improvement on previous devices, still needs more improvement. So we're delighted to have this grant from the state of Minnesota focused on developing new research areas for patients with diabetes with the ultimate goal of curing diabetes. So this grant is involves a group at the University of Minnesota and us. And here I work very closely with Dr. Andy Basu, so he and I share leadership of several research protocols, and this will be an expansion of that work. So the current work is to develop a new device, a new method to measure glucose continuously. So this will have, this could have at least two main applications. One application would be to improve the artificial endocrine pancreas, which is one exciting way of treating type 1 diabetes. And a second application would be to, in the clinic, be able to assess what is happening to glucose for patients with all kinds of diabetes so that we can better advise them on their treatments. We are excited to be working with Dr. Kester at the University of Minnesota, and he brings his engineering expertise, and he's going to use that expertise to develop this new device, which will have various components. So there's expertise in nanomaterial, there's expertise in small molecule sensing and glucose capture that are important before this device can be developed further. So we hope to use this device in biologic systems such as animal models, and of course what we have most experience with, and that is humans. You know, it's very exciting to be able to work with researchers at the university. So in the last couple of years, we've had multiple interactions with various research groups there, and the additional research money now coming in is another incentive to work more closely with them. So I think for us, on our side, it's exposure to various basic concepts and departments, and I think from their side, I'm sure they're excited about having more patients that can be helped, you know. So it's a win-win, I think. It's and of course, going to a university campus always brings a certain energy. I think it's younger people and so enthusiastic all the time. It's just so energizing and inspirational.